Good morning, ladies and gentlemen. My name is Kristian Anderson, and thank you for attending my portfolio review. To start off with, just a little bit about myself. I am a creative technologies major with minors in environmental science and economics. I have always enjoyed being outdoors with my family. I was a member of my county's 4-H club from 8th grade up through high school. I've gardened for most of my life. I've been around gardeners for most of my life. In fact, last spring, I actually installed a drip irrigation system in my family's garden here at our house, which I actually learned how to do from my job at Season's Harvest and Martha's Herbs, the student-run crop farm and production greenhouse, respectively. But now, why am I telling you all of this? Well, these experiences have directly led to the theme that's covered most of the projects I've worked on at my time in creative technologies, and even a little bit before it. And that is technologies that help users have positive interactions with, as well as improve the environment. Now, what exactly do I mean by this? Well, first of all, when I say environment, I'm talking about the natural environment. And then positive interactions, pretty much any action that imprints a good memory of just enjoying the outdoors into someone. So whether that's making it easier, more enjoyable to like hike, backpack, fish, that sort of thing. And for improving the environment, technology that helps reduce someone's destructive footprint on the environment. With examples of this being things like the reusable water bottles that you've been seeing starting to replace disposable ones. And also any sort of technology that just helps people make themselves more aware of their impact on the environment, which is actually what my first project aims to do. So this was actually made while I was still an environmental science major. It was done as part of the intro-level class on geographic information systems here at Barry, so very much a class on modern map making. Now, what these maps show is how much of the natural floodplains of the Oost-Nala, Coosa, and Etowah rivers have been cut off due to pieces of infrastructure, so things like rail lines, being built up around the rivers. Now, this is actually a bit of a problem because of nutrient deposition. Well, because whenever a river floods, what it actually does, well, one of the things it does along the area that it's flooding is deposit very nutrient-rich silts and sediments along this ground, so pretty much free natural fertilizer. So you'd imagine that if all of a sudden part of an ecosystem gets cut off from the supply of fertilizer, the health of that ecosystem will start to degrade. Now, which, as you can see here, the total reduction in floodplain size for the parts of these rivers outside of Rome city limits is around 38%, and for the areas inside of Rome, it's around 50%. And I found this out using ESRI's GIS software package called ArcGIS, specifically the ArcMaps program, which really, this is my first introduction to anything even remotely related to a CAD software. Pretty much something where you can take in like actual real data and values and then get an output that's actually useful at the end. Which in particular, this is useful for city planners, letting them know, well, first of all, where to preferably not build a city in the first place, but also if they're going to build it along a floodplain, how to do it in a more sustainable fashion. Now, my next project is actually my first proper creative tech project. It's the Sower Saver. Now, the Sower Saver was actually directly inspired by my time at Season's Harvest. So at work, whenever we went to plant seeds, we'd have to actually get on our hands and knees and bend over the holes with a trowel to well, actually dig the holes and plant the seeds. But you see, my family has a history of bad joints, and I tend to get dizzy easily from bending over for long periods of time. So I made the Sower Saver. And now how it works is you essentially you use like a small shovel, you dig a hole, but then you actually position the center shaft of the device over the hole, and then you drop your seeds in through a funnel at the top, which actually 3D printed, by the way. Now, because the device is made mostly out of hollow EMT conduit, the seeds will actually go down this tube into the hole that you've just dug. So then you can just cover the hole back up with with some dirt you kicked from your foot, and then you're done. You can move on to the next hole. So as you can imagine, this would lead to a much more positive and pain-free experience for gardeners with bad joints like myself, or more senior gardeners who want to be able to keep enjoying the outdoors even later into their lives. Now, this was also my first foray into agricultural technologies, which, as you can imagine from my past experiences, was probably bound to happen sooner or later. But now the next project, the indexer, was, well, now this is my first introduction to working with electronics and Arduinos. And then the goal of this project is to make it easier for someone to know whether or not they need to put on sunscreen at a given moment. Because whenever you look at like weather websites, not only will they probably not be showing the UV index for the specific location that you're at, it might also show you, say, the value they expect it to be at the height of the day or an average, or the like. So how this device solves this problem is by using this UV sensor right here to figure out the UV index, and then it will cause this RGB LED to shine different colors depending on the UV index. So if it's green, it means that you don't need sunscreen. If it's yellow, that means you should probably put on sunscreen, but if you wear some protective clothing or a wide-brimmed hat, you could probably get away with it. But if it's red, yes, you absolutely 100% need to put on sunscreen. Now, the interesting thing is that if you flip this switch, you're essentially telling the indexer, hey, I put on sunscreen now, how long can I stay outside? And so depending on the color of the LED, it'll tell you how long you can stay outside. If it's green, there's practically no limit to how long, as long as you reapply per various health organizations' guidelines. If it's yellow, you should probably limit your exposure to 1 to 2 hours. And if it's red, you really just need to do what you got to do outside and come back inside. Now, so as you can imagine, this would help people avoid the very painful situation of getting sunburned, and help them develop better habits around sunscreen. And as I mentioned, this is my first experience working with Arduinos, and also the Arduino Nano, the microcontroller I've probably used the most in my projects, including the next one, the weather widget. Now, the weather widget was a hackathon project, so it was made within 4 hours, and it is designed to be a pocket weather station for hikers, backpackers, and really anyone who's going to be outside of a reliable internet connection. So the idea is that if someone has some basic knowledge of weather forecasting, they can use the data that the weather widget collects, which is temperature, pressure, and humidity, and will be able to forecast the weather maybe a day or two in advance, which could help them avoid the situation of being in the middle of a long hike, say along the Appalachian Trail, and all of a sudden it starts downpouring on them, and them having no prior knowledge whatsoever. So needless to say, this could help avoid that very potentially painful, dangerous, and even embarrassing situation. Now, something very important about this project, it was the first time I ever used the BME 280. It's this little purple sensor here and here. Don't worry, you'll see a better picture of it later. Now, this is actually a very interesting sensor because this one sensor can measure temperature, pressure, and humidity, which makes it very popular for weather stations, and a very good fit for my next project, right, which I view as being like the ultimate expression of my theme. And that project is the ground hound. Now, what the ground hound does is make it easier for farmers to know the conditions within their fields. Those conditions being soil moisture, so they know whether or not they need to irrigate at a given time, temperature, so they have an idea if they should go ahead and plant certain crops now or wait, or if they shouldn't bother at all, and humidity, which would be another statistic helping them figure out the climate around their fields and what vegetables or fruits would probably grow the best. Now, as I said, the atmospheric data collected by the lovely BME 280, which actually it does have a small issue with self-heating. However, that problem was addressed in the code for this project. And then currently, moisture data is being gathered by a resistive sensor. Now, originally, I had designed a passive type of sensor, which doesn't have some of the issues of the resistive. Mainly capacitive sensors have much less of an issue with corroding. But unfortunately, when I went to go and test the sensor, the values just ended up being way too erratic to be useful at all. So I ended up going back to a resistive sensor just to get some data to show for user testing. But anyway, the sensor data is fed into a company called Heltech's version of an ESP32. Now, the interesting thing about these is that they're enabled with a wireless transmission technology called LoRa. Now, LoRa is a low power but very long range form of transmission. Depending on the antenna you attach to these modules, you could get a range from 2 to 20 miles. However, you can't directly use a LoRa signal to upload anything to the internet, so you have to have an intermediate gateway to convert that LoRa signal to a Wi-Fi signal, which is just what this single ESP32 hooked up to ground is for. Now, once that data gets transmitted as a Wi-Fi signal, it gets uploaded to a database and then to this website. Now, really, all this website shows is pretty simply air temperature in degrees Fahrenheit over time, relative humidity, and volumetric soil moisture over time. Now, what I mean by volumetric soil moisture is if you were to say collect 1 cubic foot of material from the ground, this would tell you what percentage of that material is made out of water. Now, why do I think this is the ultimate expression of my theme? So not only can this let a farmer have an easier time working out in the environment and even trying to create their own environments, but also it can prevent them from causing any sort of harm to the environment surrounding them. For instance, like it can prevent them from, first of all, using too much water, which in and of itself leads to some resource waste, but also if you use too much water, you can also end up washing out a lot of the fertilizers you just put on your field, which not only wastes money, but it can also lead to contamination of local waterways as well. Now, now that you've heard what my past projects have been, let me talk about the future. So first of all, I actually still have some coursework that needs to be finished up. I'll be graduating in December 2020, so I still have a summer and fall ahead of me. Now after that, for career goals, I'd like to continue designing technologies intended for use outdoors, especially horticultural technologies, so technologies devoted towards growing plants. That being said, I'm actually open up to any other interesting opportunities that present themselves. So there'll be jobs doing anything from PCB design, getting back into GIS, or even just continuing to practice horticulture. I like growing plants, and if I can make a living off of it, why not? Or even working in some other industries that I've always been interested in, which if I'm doing qualified for, I'd like to give a shot. These include the aerospace, defense, and cybersecurity industries. And then as far as projects go, I actually really love to continue working on the ground hound. There's a lot of potential there that I really think needs to be explored. So I'd like to continue user testing and integrating their feedback and resolving those capacitive sensor issues, because really they're just a much better technology than the resistive sensors, as well as converting it to a modular design so that a farmer can actually pick and choose what capabilities they want, so they're not wasting money on features that they don't want, and they can really just fit the sensor to their specific needs. So with that being said, thank you for attending my portfolio review. Are there any questions?
Nice. Thank you very much, Kristian. We appreciate that. So, and I also want to give a big welcome to Jessica, who joined us. So thanks for being with us, Jessica. So, all right.